This cell is going to have the initial phase starting at resting, which is phase 4. Right? Then it's going to rapidly depolarize. Okay, it's going to go all the way up, the movement of sodium only. Right? Then it's going to start repolarizing very slightly here. And then it's going to go through a sort of a delay or a plateau phase here, where not much is changing. We're going to talk about the channels in a minute. Right? And then it's going to repolarize back down to resting. Okay? So as a result, there are 4 phases here. Oops. I did not mean to do that. All right, so we got phase 4. Okay, so we have 4 phases here. Let's talk about what's going on in each of these phases. So let's start with the pink. So the pink is this rapid depolarization. That is called phase 0. This is phase 0. Right? So in phase 0, we have the opening of sodium channels. Okay, nothing very complicated. We just have opening of sodium channels here. This is just going to increase the membrane permeability for sodium. Sodium rushes in, this rapidly depolarizes the membrane, and we result in this nice spike here up to about positive 30, positive 40 millivolts here. So this nice steady spike is a result of one channel opening and rapidly depolarizing the membrane, that's sodium. Okay. The second spike, also nice and easy. This sodium channel closes, which is phase 1. All right, that's shown here in blue. So in phase 1, we have the closing of that same channel. Oops. Okay, and as a result, we have the decrease in the membrane's permeability for sodium. And so because we have that closing, this membrane is going to start to try to repolarize. All right? And if nothing else happened, it would have rapidly repolarized. Okay? But something else does happen, right? Something else does happen. In red here, we have 2 events that are going to counteract that closing of the sodium channel. We have the opening of potassium channels, right? I'm sorry, the opening of calcium channels. Forgive me here, guys. So the opening of calcium channels and the closing of potassium channels. So you remember we said when the pacemaker cell was depolarized, that triggered the opening of potassium channels. When this cell is depolarized, this triggers the closing of potassium channels. And that was that contrast that I was trying to draw out earlier. Okay, so when this cell is depolarized, that triggers the closing of potassium channels, and then calcium channels are going to open. So because this happens, that is going to sort of counteract the closing or the inactivation of these sodium channels. I'll say that again. So if the sodium channel opened, we depolarize the membrane nicely. If it closed, the membrane would want to rapidly repolarize, okay? Because now it's going to get back negative. That's not going to happen. Why? Because we're going to now close potassium channels. So potassium is no longer being pushed out of the cell here. That's going to slow things down. And then we're going to open calcium channels. So that is going to further counteract the inactivation of sodium. And so what we're going to have here is a plateau phase. So this is called the plateau phase. And this is where the membrane sort of halts. It just stays nice and steadily depolarized. Okay, so this is called the plateau phase. And that is caused by that sodium, that potassium and calcium channel sort of halting the action of the closing of that sodium channel. Okay? And so here we have an increase in the permeability to calcium and a decrease in the permeability to potassium.